Okay, this will be just a quick video and just show you a couple of examples of some specific times of what to pick for you. So in the first example, you see a natural log. And anytime you see a natural log in the numerator and an x in the denominator, then that should scream to you, let u be the natural log of x. Not the power, just the natural log of x. Because when you do the derivative of natural log of x, it's 1 over x dx. So when I look at this problem, that easily then becomes u to the 6th du. And that's a very easy integration in which to perform. So that would just be u to the 7th over 7 plus c. So that means this particular integral with a natural log then would be the natural log to the 7th of x over 7 plus c. So again, that's whenever you see a natural log of x in the numerator and 1 over x and an x in the denominator. I suppose you could also have a natural log of x in the denominator and an x in the denominator as well. And your u would still be the natural log of x because that derivative would be in the denominator. Okay, second example. You see tangent and secant squared. I don't care what power this power is on the tangent, but because I see secant squared, that means u will be a tangent. And notice they're the same angle, so that's good. And I don't want to put the power on tangent because then that would be a chain rule, and that's not going to be what is there. So the derivative of tangent is secant squared times the derivative of x over 2, which would be 1/2 dx. Okay? So we have this extra 1/2 here. So when we integrate, if I write u to the 7th du, my du has an extra 1/2, so I put a 2 out in front in order to compensate for that. So then that would become 2 times u to the 8th over 8 plus c, which means that this integral then is going to be, that'd be 1/4 tangent to the 8th of x over 2 plus c. So no matter what the power is on the tangent, if there's a secant squared, your u is going to be your tangent, especially when the angles are the same. If the angles aren't the same, that's a different story, and we'll talk about how to deal with that at a later date. Okay. E is sometimes an issue as well because kids want to just let u be e to the x. You want to let it be as much as you possibly can. So we talked the first day in the video about if there's a negative exponent on e, including that negative exponent in the u. Well, in this particular case, I'm going to let all of the denominator be u because du is just negative e to the x. And I have an e to the x in the numerator, e to the x dx. I have an e to the x in the numerator of my original problem, so that's going to work out well. So this integral then becomes u to the negative 1 du. I have an extra negative, so I needed a negative out front. Hopefully you remember that when you integrate something to a negative 1 power, if you do a power rule, you'd be dividing by 0, so that means there's a special rule, and that is that it's the natural log of the absolute value. But I have a negative out front, so that means it's the negative natural log of the absolute value of 5 minus e to the x. And don't forget the cupcake. Oops, I wasn't really supposed to put that in there. Natural log of u. So over here, it would be negative natural log absolute value 5 minus e to the x. And evaluated from 1 to 2. Okay? Notice I didn't change my limits of integration over here. I left it in the original problem. I think that's easier. So if I plug in 2, I'd have negative natural log of the absolute value of 5 minus e squared plus, because it's negative, minus, and then minus a negative would be plus, the natural log of the absolute value of 5 minus e. And remember that on the AP test, they like to test your log rules. And since that's a subtraction, that could really become a single log with the positive on top and the negative on the bottom. And that would be my answer. Okay, hopefully that clarifies a little bit about some special cases, and we will continue to practice in class.